What type of stationary point does y equals x to the 4 have? This example is just here to illustrate a point that I made in the introduction to this section. So let's just do y equals x to the 4. Let's just graph that. Now we can see that it has a local minimum. So it's got a local minimum. And now let's do it using calculus. So y is x to the 4. dy dx is 4x cubed. And then 4x cubed equals 0 means that x is 0. So it's at the point where x is 0 and y is 0, so it will be at the origin. And d2y dx squared is 12x squared. But d2y dx squared, evaluated when x is 0, is 0. So here's a situation where the second derivative is equal to 0, but we know that we have a local minimum. And that's why you can't rely on the second derivative for finding the nature of a horizontal point on the graph, a stationary point on the graph. So we'll see when we do the second derivative test, but we have to use another technique if we get that situation. We can easily produce a graph that has a local maximum by just doing negative x to the 4, and then it will go that shape. And if you look at y is x cubed, that does have a horizontal point of inflection. So d2y dx squared is 0 at a stationary value actually gives you no information whatsoever.